So good morning students, welcome to my channel Common Sense Explore. Today I will explain the third part of this video, and here I will discuss about the few important topics. First topic is leakage current, denoted as I naught. So जैसे नाम वैसे काम, बेसिकली इसका कोई काम नहीं है, मतलब सिर्फ दिस इज एन अनवांटेड करंट इन सेमीकंडक्टर। वैसे इसका बहुत सारे नाम भी है, जैसे कि इसको बोलते हैं माइनॉरिटी कैरियर करंट बिकॉज इट इज जनरेटेड ड्यू टू माइनॉरिटी कैरियर। इट ऑल्सो नोन एज थर्मली जनरेटेड करंट। Thermally generated current means this current is due to temperature. It is completely temperature dependent. Please remember, this is also known as reverse saturation current. So why reverse and why saturation? Because it works in reverse bias condition. The biasing means the application of voltage. This current basically generates in reverse bias condition, okay? And saturation means it is independent of applied voltage. That means if you apply some voltage, this current will not change, like Ohm's law. ओके, ओम्स लॉ में क्या होता है, जैसे कि वोल्टेज इंक्रीज होने से पोटेंशियल डिफरेंस अगर इंक्रीज होगा तो करंट भी इंक्रीज होता है, ओके? लेकिन यहाँ पे वोल्टेज इंक्रीज होगा कि डिक्रीज होगा इसमें कोई फर्क नहीं पड़ेगा लीकेज करंट को, ठीक है? लीकेज करंट इज ओनली डिपेंड्स ऑन टेम्परेचर। ये वोल्टेज के ऊपर डिपेंडेंट नहीं है, सिर्फ टेम्परेचर के ऊपर डिपेंडेंट है। तो वन इंपॉर्टेंट थिंग इज दैट दिस I0 लीकेज करंट इज डायरेक्टली डिपेंड्स ऑन माइनॉरिटी कैरियर, and this minority carrier depends on temperature. That's why I0 is depends on temperature. So first is I0 depends on minority carrier depends on temperature, so I0 depends on temperature, okay? So this is how you have to remember. Leakage current I0 for germanium, it is in microampere range. Micro means 10 to the power of -6, this range. And for silicon semiconductor, it is nanoampere range, means 10 to the power of -9, okay? Basically it is an unwanted current, तो ये करंट जितना कम होगा उतना अच्छा है, ठीक है? तो that's why silicon is better than germanium. लीकेज करंट जितना कम होगा उसका थर्मल स्टेबिलिटी उतना ज्यादा होगा। That's why silicon has higher thermal stability than germanium. That's why silicon is used in switch. Why switch? There is no false triggering, and because it has a very few leakage current, okay? 10 to the power of -9 ampere means only little bit. How this current will change with the temperature, that I will explain here. So the next one, for 1 degree centigrade of temperature, this I0 increases. This upper arrow means it is increases almost 7% for both silicon and germanium. For 1 degree centigrade, I0 increases 7%. Let us suppose at temperature T equals to 10 degree centigrade, the current I0 leakage current was suppose 20 microampere, okay? So if you increase 1 degree only, 1 degree means from 10 degree to 11 degree centigrade means only changes is 1 degree. So this I0 will increase 7%, means 20 microampere जो था उसके साथ 7% increase हो जाएगा। इसको solve करोगे तो तुम्हारा आंसर आएगा 107 by just like a percentage calculation, okay? So 7% I0 will increase. So this will be the current after increasing 1 degree centigrade. For 10 degree centigrade increase of temperature, this leakage current I0 become doubles. So that means suppose at T is equals to 10 degree centigrade, I am taking the same example, I0 is equals to 20 microampere, let us suppose. So now at T is equals to 20 degree centigrade means the increase in temperature is 20 minus 10 degree. So 10 degree में डबल हो जाता है, so I0 इसका डबल हो जाएगा, 20 था, 20 का डबल क्या हो जाएगा, 40 माइक्रोएम्पियर हो जाएगा, okay? So for every 10 degree I0 will be doubles. So this is how I0 will changes with the temperature. So this change in temperature, the formula is I0 of T2 equals to I0 of T1 2 to the power of T2 minus T1 by 10. This is the formula. From this formula you can able to solve. I suppose T1 equals to 10 degree centigrade. I0 of T1 was 10 microampere. T2 is equals to 20 degree centigrade में I0 of T2 क्या होगा, and what is the final leakage current at temperature T2. So now you have to put here, so I0 of T2 you have to calculate is equals to I0 of T1. I0 of T1 is 10 microampere, 10 into now 2 to the power of T2 minus T1, T2 is 20 minus T1 is 10 by 10. It will be coming 10 into 2 to the power of 20 minus 10 is 10, 10 by 10 is 1, so 2 to the power 1, 10 into 2 it becomes 20 माइक्रोएम्पियर. सो इसका मतलब जो 10 माइक्रोएम्पियर था वो हो गया 20 माइक्रोएम्पियर. देखो कितना टेम्परेचर इंक्रीज हुआ, 10 डिग्री, 10 डिग्री इंक्रीज. सो एवरी 10 डिग्री इंक्रीज द करंट बिकम्स डबल्स. आई ऑलरेडी टोल्ड यू, राइट? सो दिस इज हाउ यू हैव टू सॉल्व. सो दिस इज द मेन फॉर्मूला you have to remember. Okay, so here in this video we will learn about the resistivity of the material. So it is the actually properties of the material. It cannot change with the length or cross sectional area of the material. Resistivity is denoted as rho. We know that the resistance R is equals to rho into L by A. So from here rho can be written as R into A by L. Okay, the unit of R is ohm into A means area unit is meter square in SI unit, and a length unit is meter. So meter cancel, so unit of resistivity is ohm meter. Okay, ohm into meter or ohm meter, or you can say ohm meter. In this way you can write, or in CGS it is ohm centimeter. So the definition is specific resistance of the material is known as resistivity. Okay, so the specific resistance of the material is known as resistivity of the material. So here is a comparison between a metal means conductor, and semiconductor. In case of metal, one thing always remember, PTC. PTC stands for positive temperature coefficient of resistance. What does it mean actually? The meaning of this sentence is that if temperature increases, resistance also increases. In case of semiconductor, it is NTC. NTC means negative temperature coefficient of resistance. If temperature increases, resistance will decrease. Positive means direct relation, negative means opposite relation. You can see here, if temperature increases, resistance increases, then it will be positive in case of metal. Now in case of semiconductor, NTC means negative temperature coefficient of resistance. That means when temperature increases, resistance will decrease. Here in this video I will explain about the conductivity. It is denoted as sigma. Conductivity is just the reciprocal of resistivity. By definition, it is the current carrying capability of any material, that is called conductivity. So the definition is current carrying capability of any material is known as conductivity. As I told you, it is the reciprocal of resistivity. So I can write sigma equals to 1 by rho. Rho is the resistivity. So what is the unit? The unit of rho was ohm meter or ohm centimeter. So the unit of conductivity is ohm into meter. So that means it can be written as ohm into meter to the power of -1. Sigma depends on three factors. So it depends on, one is carrier concentration. Please remember, in semiconductor there are two types of charge carriers. One is electron and another is hole. N is electron concentration, P is known as hole concentration. But in case of metal, there is only one charge carrier present, that is electron only. First is carrier concentration, then electronic charge. Carrier concentration is either N or P. Okay, and electronic charge is denoted as Q. The third point is mobility. It is denoted as mu. So electron mobility is mu n and hole mobility is mu p. So this is the three factors on which the conductivity depends on. Conductivity equals to carrier concentration into charge into mobility. So this is the formula you have to remember. So conductivity is denoted as carrier concentration into charge into mobility. If any of these factors will changes, automatically conductivity increases, because all are directly proportional. For metals, only one type of charge carrier is present, that is called electron. In case of metal, there is no concept of hole, so electron concentration is known as N. So in case of conductor, it is sigma N, because only electron is present. So conductivity due to electron is denoted as N Q mu n. Okay, mu n means electron mobility, Q means the charge of an electron, and N is the electron concentration. So this is for metal. And for semiconductor, two charge carriers present, one electron as well as hole Okay, that means N and P, both charge carrier present in case of semiconductor. Sigma is due to electron as well as hole. So due to electron, the conductivity is NQ mu N, plus due to hole it is PQ mu P. ओके देखो यहाँ पे Q का कोई चेंज नहीं है, बिकॉज Q इज द चार्ज, इलेक्ट्रॉनिक चार्ज, दैट इज वैल्यू इज 1.6 into 10 to the power minus 19 coulomb. Okay, so it is electron concentration, it is hole concentration, and it is electron mobility, it is hole mobility. So this is for semiconductor, because semiconductor is bipolar. Bipolar means there are two charge carriers, one is electron, another is hole, N or P, and for metals only electron is present, that's why it is only N. In case of metal, electron concentration is independent of temperature. So that means if temperature increases, I am talking about only metal. So if temperature increases, this electron concentration will remain constant because it is independent of temperature. Only this mobility will decreases. If mobility decreases, that means conductivity is also decreases. Conductivity decreases means resistivity increases. So that means that's why it is called positive temperature coefficient of resistance. But in case of semiconductor, electron and hole concentration will increases, but mobility decreases. Here you can see I have given a larger arrow than this smaller arrow, because this decrease value is smaller than this increase value. So that's why overall conductivity of a semiconductor increases with the temperature. So that means if temperature increases, conductivity of semiconductor will increases. But in case of metal, temperature increases, conductivity will decreases. So that's why it is known as PTC of resistance, and this is known as NTC of resistance. Actually, in case of semiconductor, conductivity mainly depends on carrier concentration. It mainly depends on N and P, because with the increase of temperature, mu N and mu P also decreases. But this increase is much more than this decrease. So that's why overall it is increases. Okay. The next part is conductivity sensitivity. How conductivity will change with temperature, that is known as conductivity sensitivity. For 1 degree centigrade, the sigma of germanium increases by 6%. That means for 1 degree centigrade increase of temperature, conductivity of germanium increases by 6%. For 1 degree centigrade increase, the conductivity of silicon increases by 8%. Definitely silicon is better because its conductivity increases with the temperature more than germanium. Next topic is current density. Denoted as J, and J is equals to, this is the formula, you have to remember, sigma E. J is equals to sigma E, where J is the current density, sigma is the conductivity, and E is the electric field. So this is called conductivity and this is the electric field. Current density means current per area, means यूनिट एरिया में कितना करंट जा रहा है, तो करंट पर एरिया. सो करंट का यूनिट क्या है, एम्पियर है, एंड एरिया इज मीटर स्क्वायर. सो दैट मीन्स एम्पियर बाय मीटर स्क्वायर इज द यूनिट ऑफ करंट डेंसिटी. सिग्मा फॉर मेटल NQ mu n, and sigma for semiconductor NQ mu n plus PQ mu p. So current density for metal is Jn is equals to sigma into E. Sigma means NQ mu n into E. Okay, this is the current density for metal. And for semiconductor, current density J is equals to NQ mu n plus PQ mu p into E. Q is common, so take the Q outside of the bracket, N mu n plus P mu p into E outside of the bracket. So this is the current density for semiconductor. Unit is ampere per centimeter square. Here also same, ampere per centimeter square.